Good morning, students. So today's class we are going to study about the spectral analysis. So actually, what is the name called Cepstrum? It is derived from spectrum only. So when you reverse the first four letters of spectrum, this you will be getting the Cepstrum. So like that, in the case of frequency, when you reverse the first four letters, that is first this when you reverse this particular letters, it will be Q frequency. Then here lifter filter, when you reverse the first three letters, it will be lifter. So if you see a complex spectrum, so this complex spectrum determines the shape of the wavelet. So a complex spectrum, so it is defined here as x bar of tau equal to the inverse Fourier transform of the logarithm of Fourier transform of x of t. That means to the input signal, you are going to apply the Fourier transform. Then over the Fourier transform of x of t, you are going to apply the logarithmic function. The entire thing, when you are going to apply the inverse Fourier transform, you will be getting the complex spectrum. So now to analyze in detail, let us consider x of n. When you take the z transform, you will be getting x of z. Then in case of magnitude function, Cm of n is nothing but 1 by 2 pi integral minus pi to pi ln of modulus of x of z e power j omega n d omega. So in case of phase angle, it is given by 1 by 2n minus in pi to pi theta of omega e power j omega n d omega. So this formula represents like an inverse Fourier transform which is applied over the signal with respect to the magnitude and the angle. That means it is applied inverse Fourier transform applied to the substral signal. So when you are expressing that substrum in terms of C of x of z, so this is equivalent to natural logarithm of x of z. So the inverse discrete Fourier transform of the substrum, it is given here, and whose magnitude and that angle is represented by modulus of x of omega is a magnitude and e power j theta omega is an angle. So when you apply the natural logarithm of for it, it is natural logarithm of x of omega plus j into theta of omega. Then we are going to apply the inverse Fourier transform. After that, when from that equation 2a, 2b and then 4, that is from the equation 2a, 2b and then 4. So we can observe that x bar of tau equal to the inverse Fourier transform of logarithm of Fourier transform of x of t, and the power substrum is represented by xp bar of tau equal to inverse Fourier transform of logarithm of Fourier transform of x of t the whole square into whole square. So this is how the substral looks like, signal looks like. Okay. So thank you.